Attends to this next lesson. As you can see, it's called special products. So in our very last lesson, we practiced multiplying surds together. And in that lesson, we looked at binomial products. Now, there are some special binomial products that we might come across, and I've listed the 3 of them here. So as you can see, we can get products where we have a square involved or squared bracket involved. So a plus b might be one case that we come across, or a minus b alternatively. Now these are special identities, and we actually have a fast way of expanding these, which I'll remind you of in a moment. The last one that we might come across looks like this. So identical terms in a way, apart from one, and that's with this negative in the second bracket here. So a plus b multiplied by a minus b, or of course that could be reversed. What I want us to be able to do is to recognize first that we are working with a special product, and I'll first remind you of what happens when we do expand these, because they will expand the same way every time. So it means that we have, some shortcuts to work with. So with this first one, this is going to expand out as, once I get a pen that works, maybe I'll try a different colour. Oh, switch that around. Here we go. This will come out as first term squared plus a by b, which is the outer 2 terms, a by b again, plus b squared. And of course this is because it looks like this. So the first terms, the outer terms, the inside terms, the last terms. When we collect the like terms, as you can see, a plus b squared will always expand to a squared plus 2ab plus b squared. And we're going to use that, of course, with surds, and it is going to allow us to, a bit of a shortcut, expand these quite quickly and efficiently. Likewise, if I consider, I'll just move this over a little bit. If I consider a minus b squared, that would be a minus b by a minus b. Let's do this again because it'll have a slightly different result to before. First term a squared, then we're going to have a by negative b, so negative ab or minus ab. Then inside terms, negative b by a, so that's negative ab again, and negative b by negative b is positive b squared. Collect those like terms again, and there we have our second identity for our a minus b squared. So I'm going to make use of those in a moment when I do a few examples with you. The last one I wanted to remind you of, because as you have actually seen this before, is this one down here. Now, this one here, you might recall, we call this the difference of 2 squares. I do apologise, my pen's playing up a little bit with me today. Difference of 2 squares, and I'll show you why. Let's expand it. First of all, a by a. Next, out of terms a by negative b, so negative ab. Inside terms, it's going to be positive ab. And then finally, b by negative b minus b squared. These are actually going to cancel out here. Minus ab plus ab. As you can see, all we are left with is a squared minus b squared, and hence the name, the difference. So this difference in the middle here, minus, of 2 squares, a squared and b squared. Now these, when you're using surds, are really, really nice, because what happens is, because we're squaring the term, the surd actually, the square root sign really cancels out, and so we are left with an integer when we do this one. I'll show you in a moment. Let's first try a couple where we've got a plus b squared or a minus b squared. So I'll just find that for you. It's the next page, which is this one here. Okay, so first of all, we want to recognize that we do have a special product. We do have a way that we can do a little shortcut with this one. This, of course, is in the form a plus b all squared. Doesn't want to change colours for me today, which is very strange. I'll be stuck with white. I'm sorry about that. Let's expand this out then. Of course, what we're going to get is a squared plus 2ab plus b squared. Because I know that, I'm just going to work with that. I'm going to square this first term, so 2 root 3 all squared plus 2 by the first term, my a term, 2 by a, by b, which is root 2, plus b squared, which is root 2 squared. Next step, I want to square this. So that's going to be 2 squared by root 3 squared. So root 3 by root 3. 2 squared is 4. Root 3 by 3 is 3. So 4 threes. Left with 12. Next one, 2 by 2 is 4. But then I've got root 3 by root 2. So I'm going to have 4 root 6. And finally, root 2 by root 2 is 2. So I'm left with 14 plus 4 root 6. Let's try another one. As you can see, we're in this form now. A minus b all squared, and of course that's going to be a squared minus 2ab plus b squared when we expand it out. So let's do that now. A squared is 4 root 2 all squared minus 2 by the first term, which is 4 root 2, by the second term, which is 3 root 3. Next, I want to add 3 root 3 all squared. And that's my b squared term. Okay, let's have a look at this then. 4 squared 16, 16 by root 2 by root 2, which is 2. 16 by 2, 32. Minus 2 4s are 8, 8 3s are 24. Root 2 by root 3 is root 6. Plus, now I've got 3 squared's 9, but I've got root 3 by root 3, which is 3. So 9 3s, 27. Finish it off. 32 and 27 will give me 59 minus the 24 root 6. And that's how it's done. So that's where we had our bracket squared. What we want to look at now is one last set of examples, and that was our difference of two squares identity. So this is what it would look like as a question. You've got your first bracket here. We've got identical terms, but here they're being added, and here one is being subtracted from the other. So one of the key things, obviously, is to first recognize that you're working with the difference of two squares. One will be, I've written it the other way around, as you can see, because sometimes the first bracket could have the negative in it. So don't be alarmed by that. So let's start off. We know that this is going to expand out and simplify to a squared minus b squared. So a squared will look like that. B squared, we'll do minus of course, b squared will be 2 root 3 squared. As you can see, these are a lot less messy than the other ones, that's for sure. So this first one, 3 squared is 9, root 2 squared is 2, so 9 by 2. And this one here, 2 squared is 4, 4 by 3, 12. So we're left with an integer, we're left with just 6. D. Again, it's clearly difference of two squares. I've got an A term, B term, one's being added, the other was being subtracted in this bracket. It is going to simplify, it's going to expand and simplify, I should say, do a squared minus b squared. In this case, we're just working with a number, not a surd as the second term. So this first one, 4 squared 16, we need to do 16 by 3. So that's going to be 48. 7 squared is 49. We're actually left with -1 with this one. Okay, we are going to have a go at this in our very next lesson. I do hope that you have written any questions down. I will reiterate that because it's really important, if you have had any questions throughout these, that you do let me know when I see you next. So thank you very much, Year 10s, for watching this video, and I'll see you in class.